Welcome to my presentation. This presentation is part of the playlist The Chain Rule. In this presentation, we will be solving problems using the chain rule. Let's look at some example problems. Let's say we have a function y is equal to x squared minus 2x plus 3, the whole thing raised to the power of 3, and we want to find the derivative of this type of complex function. This is the complex function. So we want to identify the inside function and we want to identify the outside function. Let us call the inside function as u, and therefore let us call that as equal to x squared minus 2x plus 3, and therefore y will be equal to u to the power of 3. So now we have separated it into two different functions, an inside function and an outside function. We can differentiate these two functions separately and then apply the chain rule and arrive at our answer. So let us see how we can do that. U is equal to x squared minus 2x plus 3. U is a function of x. Therefore, we're going to differentiate it with respect to x. Du by dx is equal to d by dx of x squared minus 2x plus 3. D by dx of x squared, we can use the power rule here, and when we use the power rule, it translates to 2 times x to the power of 2 minus 1 minus d by dx of 2x is 2 and d by dx of plus 3 is 0, which is a constant. So therefore, we can simplify it as 2x minus 2. And then on this side, we have y as a function of u. Y is equal to u cubed. Therefore, we can differentiate it with respect to u. dy by du is equal to d by du of u cubed. So we can use the power rule here. When we use the power rule, it simplifies to 3u to the power of 3 minus 1 or 3u to the power of 2. Now we can use the chain rule. The chain rule is stating that dy by dx is equal to dy by du times du by dx. We have the value of dy by du and we have the value of du by dx. So dy by du we can write as 3u squared as I shown here, and then we can write the value of du by dx as 2x minus 2 as shown here. Now we can simplify it. We can simplify it some more. Wherever we see u, we cannot have u as part of the answer. So wherever we see u, we're going to substitute u squared minus 2x plus 3, and that is what we started saying in the beginning of the solution process. So wherever we see u, we're going to substitute x squared minus 2x plus 3. Therefore, we can write this one as x squared minus 2x plus 3, the whole thing raised to the power of 2 times 6x minus 6. And this is how we can solve complex problems using the chain rule. Let's look at another example. Let's say this time we have a function y is equal to 3x squared plus 2x minus 1, the whole thing raised to the power of 6. We want to find the derivative of this complex function. We can use the chain rule to solve complex functions of this nature. We want to identify the inside function and also identify what the outside function is going to be. Let the inside function be u, and then we will then let u be equal to 3x squared plus 2x minus 1, like that. And therefore, y will be equal to u to the power of 6. Now we have two different functions. U is a function of x and y is a function of u. We can differentiate u with respect to x as shown here. Du by dx is equal to d by dx of 3x squared plus 2x minus 1. D by dx of 3x squared, we can use the power rule here. And when we use the power rule, we can write as 3 times 2x to the power of 2 minus 1 plus d by dx of 2x is 2 and d by dx of 1 is 0 because it's a constant. And when we simplify it, it simplifies to 6x, 3 times 2 is 6, x to the power of 2 minus 1 is x to the power of 1 or just x, so that is 6x plus 2. On this side, y is a function of u, therefore we're going to differentiate it with respect to u. dy by du is equal to d by du of u to the power of 6. We can use the power rule here. When we use the power rule, it simplifies to 6 u to the power of 6 minus 1 or 6 u to the power of 5. We can now use the chain rule. We have the value of dy by du and we have the value of du by dx. So the chain rule is stating dy by du is equal to dy by dx is equal to dy by du times du by dx. The value of dy by du we have as 6 u to the power of 5, like that. We have the value of du by dx as 6x plus 2. So we can put it together as, when we simplify it, we can write it as u to the power of 5, and then I have distributed the 6 to every one of the terms inside this parenthesis here. Every one of the terms inside this parenthesis. 6 times 6 is 36x, 6 times 2 is 12. So u we started seeing as being equal to u is equal to 3x squared plus 2x minus 1. So when we substitute that into y, we can write it as 3x squared plus 2x minus 1, the whole thing raised to the power of 5 times 36 plus 12. This is our solution. This is the way we want to be able to solve complex functions using the chain rule. Let's look at another example. Let's say this time we have a function y is equal to 1 over x to the power of 5 minus x plus 1, the whole thing raised to the power of 9. We want to find the derivative of this complex function. Here again, we want to be able to identify the inside function and then also identify the outside function. Let's call the inside function as u, and then therefore let u be equal to x to the power of 5 minus x plus 1, and therefore y will be equal to 1 over u to the power of 9, like that. Okay, we can differentiate u with respect to x because u is a function of x. We can differentiate y with respect to u because y is a function of u. Now let us start here. U is equal to x to the power of 5 minus x plus 1. We're going to differentiate it with respect to x. Du by dx is equal to d by dx of x to the power of 5 minus x plus 1. Du by dx is equal to d by dx of x to the power of 5. The d by dx of x to the power of 5, we can use the power rule here. We can write it out as 5x to the power of 5 minus 1. D by dx of x is 1, and then d by dx of 1 is 0, because it's a constant. So when we simplify it, it simplifies to 5x to the power of 4 minus 1, like that. And then here we have y is equal to 1 over u to the power of 9. We can bring the denominator, when we bring the exponent to the numerator, we can express it as a negative exponent. 1 over u to the power of 9 we can write as u to the power of minus 9, like that. So we can differentiate this function with respect to u. Dy by du is equal to d by du of 1 over u to the power of 9, or we can write this as u to the power of negative 9. So when we differentiate it, we can use the power rule here, and then when we simplify it, it's going to simplify as minus 9 times u to the power of minus 9 minus 1, and therefore it simplifies to minus 9 u to the power of minus 10. Negative 9 plus negative 1 is negative 10. Now we are ready to use the chain rule. The chain rule is stating that dy by dx is equal to dy by du times du by dx. We know the value of dy by du, which is this, and we know the value of du by dx, which is this. So now let's put it together. So dy by du is negative 9 u to the power of negative 10 times du by dx is 5x to the power of 4 minus 1, like that. But we cannot have u as part of the answer. So therefore, wherever we see u, we're going to substitute u to the power of 5 minus x plus 1. When we substitute, we can write it out as shown here. Negative 9, open parenthesis, x to the power of 5 minus x plus 1, close parenthesis, to the power of minus 10, and then we have 5x to the power of 4 minus 1, like that. We can express the negative exponent as a positive exponent by bringing it to the denominator, and therefore we can write this as negative 9 times 5x to the power of 4 minus 1, which is in the denominator, and then the part which is going to be in the denominator is x to the power of 5 minus x plus 1, the whole thing raised to the power of 10. This is the way we can solve complex problems using the chain rule. In my next video presentation, we will be solving more problems using the chain rule.